Alright guys, this is Matt with Thrive Off Grid. This is part 2 of the DIY inverter generator build. Alright, so as you can see, I got my adapter plates made. I did these on the CNC machine, but you can do this by hand. You don't need to have fancy vent holes. Just use a good old hole saw and just punch holes. You want to make sure that you got webbing in between your holes, so you don't want this to become too flimsy or anything. This has got to have some integrity. Now, I used 12 gauge steel, but I would probably, thicker is better. 12 gauge is probably going to be the minimal that you'd ever want to use. Aluminum would be a good option. Go to a good 1/4 inch thick piece of aluminum. But you could put a square plate on here. It doesn't have to be round, as long as it doesn't interfere with stuff. But you can always whack the corners off or whatever. If it were to hit the spin or whatever, you just cut it off and make it fit. But yeah, you're going to need these flanges. So when you get your flanges, just lay out the holes, punch all your holes, and then what you could do is bolt the flange to the plate, and then use it as a template to run a grinder around, cut your hole, and then use your holes as a reference to find your center, and then you can lay out your hole patterns for bolting it to the engine and then the stator. So nothing that you need a CNC machine for to do this. So this here is the adapter plate that goes to the back of the engine, and then this plate here is for the stator. So the stator is going to mount to this, and then we're going to have a cooling fan, which is one that I've had laying around. That'll go in there for cooling, and we'll go over the wiring for that and at the very end. But we're going to use the oil pressure or the oil switch to control that, so that it's not running all the time. If the engine stalls or whatever, the oil will cut the ground to a relay, and that'll cut the supply to the power supply. So all right, so I guess the first step will be to getting our adapter plate mounted to the engine. So I'm going to bring this up to the edge of the table and get your reposition here. All right. And your hole pattern for here, I used the instructions that came with the motor. So I had that those specs in the manual. So I just used that, and the hardware on this is actually SAE. I thought it was metric. So in the last video, I thought they were M8s and M10. They're actually 5/16 and 3/8. 24 thread for both sizes. So it is Imperial hardware, at least as far as the mounting goes. So I'm going to go ahead and lock that down. Alright, I'm going to double check the wrench. I don't want that coming loose. could use Loctite there, but that could make things difficult in the future. If you ever need to get that apart. Okay, now one thing I had to order are some shims to shim the taper adapter, because it was too far in this way, and basically the bolt that pushes this all together is basically going to bottom out before it really locks it in place. So I'm just going to add a shim. And if you know my my cut here on the taper adapter, I'm doing 180 from the keyed slot. Now, once this is locked on here, this isn't coming apart again. Alright, so that's a 9/16 socket. Well, I think we got it. I don't think it's going anywhere. Alright, so the next step is to assemble the stator to the mount plate and get that assembled. And then once that's assembled, then we can insert that into the rotor here, and then we can get a dimension from the adapter plate to the stator mount plate. And that's going to give us the dimensions for the depth of the housing. It's going to go in here. Alright, so once I have that depth, that's actually going to give me the measurement I need to create some spacers for welding this. So basically I'm going to have some tubes, 6 of them that I'm going to cut, and then I'm basically going to assemble this all the way around with those spacers in there, and that will ensure that this is true. You know, you don't want it built like that. You know, the two surfaces have to be true to one another. So I'm gonna put those spacers in there to ensure that that happens. And then another thing I want to go over too is when I get that dimension from this plate to here to the stator plate, that's going to give me the dimensions I'm going to use to cut those spacers. Now the thickness of the two flanges is going to be added onto that, which is going to push it up farther apart, and that will make sure that we have the clearances that we need between the two parts, so that the rotor isn't rubbing the stator adapter plate, and the stator isn't rubbing on the back side of the rotor. So, alright. Okay. So, what you're going to need for hardware for this is because these got these counter bores, you're going to want to use a socket head cap screw, an Allen socket. And probably M8, or you could use either M8 by 3 or 5/16. These are 5/16, 16, I think, or 5/16, 18 thread. But yeah, I had to improvise and cut the flange off my bolts here, and Now we're gonna kind of do it in reverse of what I was doing. So on this side, the standoffs still work just fine. Perfect. They actually work perfect. And it's actually probably easier to put together now. Alright, so I got that good and tight. Alright, so next part will be to install this into the rotary. Alright, so now be careful when you do this. Wow, that one seems cracked. Alright, because these magnets are really strong. Alright. Make sure it's fully inserted. I got 4 5/8 there. 4 5/8 there. 4 5/8 there. Alright, so remember that 4 5/8. Okay, well, now that we're there, I'm gonna go ahead and cut those standoffs, and then I guess the next part of the video will be building the housing. Alright, so we're over at the weld bench. I have my spacers cut and installed on the flanges. And then I have my the housing shell cut. Now, you, the DIYer, you may not have a CNC machine laying around, so you may want to, or you're probably going to need to source a tank from somewhere, like a propane tank or a portable air tank, and cut a section out of that to create your shell. So I cut mine, and just so the circumference dimension is 31.5 inches, and that'll fit perfect in the flange. All right, so what I'm going to do is I'm going to insert this in here. Split the difference here. Okay. Alright, so you don't have to solid weld this. You can weld it, here and here. Or if you cut this a little short, you can weld it in here. That's probably how I'm going to do it, so it'll be cleaner. But I'll probably use the holes as a reference for placing my welds. Alright. pretty much it. So and that's plenty enough weld. Alright, so I'm going to take that apart, clean it up, and get some paint on it, and then we'll move on to the next part of the build. Alright, so got this cleaned up and painted, so we can go ahead and install this on the generator. Alright, so we got bolts in good and tight. A view of this. So we got plenty of clearance. And then you can kind of see how the air will move through the housing. Alright, so the next step, I'm going to move this back a little bit. Now we got to set the air gap between the stator and the rotor. So how I'm going to do that is I'm going to wrap the stator with some thin cardboard. This is from a Coke 12 pack. So what I'm going to do is wrap that, and then that'll create like a spacer in between the rotor and the stator and the rotor, and then we can lock this down. And what I'm going to do is I'm going to pin it, because I'm going to put a 1/4 inch dowel on each side, and then that way I can remove it and put it back, and it should be in the, as long as these bolts don't ever get loosened, or them bolts ever get loosened, you'll be able to put it back together. Actually, I think one is good enough. Okay, so what I'm going to do is, because when you insert the bolts can actually force it one way or another. So I want to lock this in place where it wants to be naturally. But I want to try to get my holes aligned as close as possible before I do that. So I'm going to now, what I'm going to do now, I'm going to get a drill and make sure that I don't have any interference issues with the holes. Alright, so now I'm going to center punch it so I can drill those holes. do is I'm going to drill a pilot hole. Alright, so I got to cut some dowel, and I'll get that welded to the plate, and then I can take that apart and put it back together, and that'll conclude this part of the build. Okay. Alright, so I welded the dowels to the adapter plate. So now I can carefully install this. Watch your fingers. And there we go. As you can see, I mounted the fan on. Be mindful of the bolts on this. This fan is an 8-inch fan. Yep. So, yeah, 7-inch would be too small. You could, yeah, you're pretty much limited to an 8-inch fan. Now if they bring the fan that's supposed to go on the rotor to market, then you don't need to do the electric. But there is a fan that goes onto the back of the rotor. But apparently they're not offering that yet. And maybe if this tutorial takes off and other people start building it, then more of these parts will come to market. In fact, I may come out with this kit, and I'll have to revise it, and then see about having the taper adapter manufactured. There's a machine shop down the road that could probably make those for us. Okay, well, I did everything right in the last video, except, if you remember in the first video, I was talking about the runout on the taper adapter. Do you see how it's thin on the one side and thicker on the other? That's a problem, because you only got about, maybe, I'd say about 30 thousandths of air gap, and you know that rotor isn't perfectly round to begin with, and then you add in this, you get a stack up there, and then the alignment, you know, how true the stator is to that, you know, you got things adding up there, and I ended up having a interference issue, so I pulled it all back apart and remachined this adapter. I didn't screw it up the first time, and I should have known better. But this time I got it dialed in before I cut it out. So anyways, that is the housing installed. Yeah, something else I want to mention too, on my rotor, some of the magnets were broke. So I'm not sure if that's causing a bit of an issue or not. Let me try to put you on the stand here, because I'll need both hands to turn it over. It does spin free in there. But I think there's crud in there, making some noise, but I think it'll be alright. If not, I guess we'll find out. But yeah, I mean, if I do run into problems, I'll show it on camera. It is what it is. You know, you can only build it. It's so true, you know. I think if there is an issue, it probably is on broken magnets. But fortunately, I got the other 9500, so I could always use that one if I had to. So it's not a loss if it is unusable. But it is what it is. So anyways, yeah, that concludes this part. The next part of the build is going to be mounting that on to the chassis, our handy dandy cart. So I'll be thinking about that over the next couple days, how I'm going to go about that. I'm not a fan of that cart, actually, because of the plastic. I don't know that I'll use that in the future. I definitely wouldn't recommend it. You know, get a steel cart and weld to it, or you know, get a utility wagon, or how a radio flyer will work too. All right, well, the dog's wanting to go in, so I'm gonna cut you guys loose. Thanks for watching. We'll see you in the next one.